The variable x and y satisfy the differential equation. It is given that when y is equal to 0, x equal to 1, we need to obtain an expression for y in terms of x. Step number 1 is separating the variable. So many of you will do slow and steady this way. I'm going to put a dx over here. I'm bringing over that side. And then this side I'm going to leave my dy. So now when you look at your x and x, they are already paired together. So you're going to rearrange and move your y. Some of you are good enough that you can just do it in the first step itself. I'm just going slow and steady here. Okay, once you're done with this, you know you need to start the process of integration. Why? When I integrate this, I'm going to get terms in y, and on my right hand side, I'm going to get term in x. Okay, now which one is easy for student? Of course, the right hand side, because you're going to push this up. You refer to your MF 19. And you're going to get e negative 2x. You copy back what you have, you take the power, you differentiate, and you write it as your denominator plus the constant of integration. Now what was challenging for student is the one on the left hand side. If you refer to your MF 19, they have already given you 1 over x squared plus a squared. When you integrate that, your answer is going to be 1 over a tangent inverse x over a. Now, what is the coefficient of my x squared here? It is a 1. The number in front of the x squared is 1. But what do I have? I am having a 9 in my question here. So what you have to do, you have to try to get it into the form given there. So let's do this separately. So I'm going to take out the 1 over a, the 9. And I'm going to write it as y squared plus 4 over 9. It's just a basic factorization. And then the 1 stays up there. And then you get the dy. Okay, now what are we doing? We are integrating. Where is my constant? My constant is this 1 over 9. So I can pull that out and I can park it here. Nothing is going to affect my solution because they are just a multiple of a constant. Okay, now see how can I write 4 over 9 as a power of 2? It's going to be 2 over 3 squared. Done. Now you can easily solve it. So you use your MF 19. You look at this particular form. Wait, let me change the color. See this part, it's exactly similar to this form here. So now when you replace, what will you get? The 1 over 9 stays there. Okay, then what is 1 over your a? Your a is what? See, how did you get this a? The a is 2 over 3. If you swap, you will get 3 over 2. You can do slow steady, no need to hurry. And then y over 2 over 3. Okay, so now let's write it here. 1 over 9 times 3 over 2. Tangent inverse 3 over 2 y. Done. So you simplify one more level. You're going to get 1 over 6 tangent inverse 3 over 2 y. After this, everything becomes easy for you. What are we doing? We go back and check. Y is equal to 0, x equal to 1. Why are they giving you this information? So that you can crack the constant of integration over here. You substitute 1 over 6 tangent inverse 0. And my x is 1. E negative 3 over negative 2 plus by c. So what's your c value? Half e power negative 3. Because this tangent inverse 0 is exactly 0. Therefore, 1 over 6 tangent inverse you rearrange. I am having a 2 here and this is a negative 2. So I am going to bring the negative upward. And I'm going to balance my denominator. You still have to rearrange to make your y as the subject. So you multiply. You bring the 6 over the other side. Can you see this 6? I can bring over the other side. I'm going to get a 3 there. The tangent you move over. Maybe at this point I just want to expand them to make my life easy. And then I will have 3 over 2 y. Okay, now rather than doing one more step, I'm just going to erase that and then bring it over the other side. So it's going to be 2 over 3 here. So this part is done. Now let's go for the second part. What are they saying? They say state what happens to the value of y as x tends to infinity. What is the meaning of x tends to infinity? X approaches a huge number. So let's go up and check here. What happens if my x approaches a huge value here? There is only x over this part, correct? So let's decompose. I know I'm just solving for e to the power of negative 2x minus 1. If x approaches infinity, my instincts tells me to find out what will it be for e to the power of negative 2x. So if you're very good in sketching, if I ask you how do you sketch e to the power of x, so I think most of you will be able to do it. This is e to the power of x. So how will you sketch e to the power of negative x? It's a reflection on your y axis. So let me show you here quickly. I'm going to erase this. So it's just going to be this way. So this is the e to the power of negative x. Now you observe the changes here. Changes on where? The x-axis. Where is my x-axis? Here. My x is taking a huge value. Okay. Let's say if my x is taking a huge value here, what kind of y value will I get? I'm getting a value which is very, very near to the 0. Can you imagine? Let's say if I extend this, it's just going to go quite near to the 0. So let's say my x value is somewhere here now. Little further, if this is 10, maybe this is like 100. Let's take it like that. So if you are taking this one, it's still lower than the original. Let's say if this is k, now you're getting k1, and that k1 is very near to the 0. So it's very obvious that e to the power of negative 2x is also approaching 0. I mean, it's approaching 0. It's not equal to 0, but it approaches 0. Therefore, e to the power of negative 2x minus 1 is also approaching 0. So when you substitute that here, what will happen to your y? Your y approaches, never write equals, because nobody knows the value of the infinity. I don't know how big is it. I know it's big, but not sure how big is it. So y approaches 2 over 3 tangent 3e minus 3. Close.